Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of Cartesian equation of plane. So as per the problem, determine the Cartesian equation of the plane that contains the points A, B and C. So let's start by writing the general equation of a plane in Cartesian form. In this equation, a, b and c are the coefficients of x, y and z terms. They also represent the components of normal vector for this plane. We are given 3 points a, b and c that lie on the plane. We can use these 3 points to find two non-collinear direction vectors for this plane. So let's start with the first direction vector. We can use points A and B. So we'll use the position vectors for points A and B. Now we can subtract these vectors by subtracting their x, y and z components. So this is the first direction vector for this plane. Now we can find the second direction vector. We can use points B and C. So we have to subtract their position vectors. Now we can subtract their x, y and z components. So this is the second direction vector for this plane. We can see that these two direction vectors are not collinear vectors because they are not scalar multiples of each other. There is no way we can multiply one of these vectors by a scalar to get the other vector. Now we can use these two direction vectors to find the normal vector for the plane, and the normal vector will be the cross product of these two direction vectors. The cross product of two vectors is a vector that's perpendicular to the two vectors whose cross product is being calculated. So that's why the cross product of the direction vectors will be the normal vector. Now we can find the cross product by stacking the y, z, x and y components of these two vectors. For the first vector, the y component is 1, the z component is 4, x component is 5, and y component is 1. For the second vector, the y component is -3, z component is -5, x component is -2, and y component is -3. Now we can find the x and the y and the z components of the normal vector. So let's start with the x component. We should cross multiply the y and the z components. 1 times -5 minus -3 times 4. I get x equals 7. Now we can find the y component, and for that we should cross multiply the z and x component. We start with 4 times -2 minus -5 times 5. I get 17. Now we can find the z component, and for that we should cross multiply the x and y components. We start with 5 times -3 minus -2 times 1. I get -13. So the normal vector is 7, 17 and -13. So that means in the general equation, the value of A is 7, B is 17, and C is -13. We can sub in these values in the general equation. Next, we have to find the value of D, and for that, we have to use one of the 3 given points. The easiest point to use will be point C because it has the smallest numbers as coordinates. So we can sub in x as 1, y as 1, and z as 0 from point C to find the value of D. I get D equals -24. So the equation of this plane in Cartesian form is so this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.